everyone. I'm glad that you've come back to see the second lesson in the linear functions unit. Today we're going to talk about graphing linear equations. We're going to talk about the different forms I can give you an equation in. We're going to talk about this at least three different forms that we're used to seeing in graphing. And I'm also going to give you some graphs, and I want you to tell me the equations. So let's start with our warm-up. So first, I want you to write a paragraph detailing who you are as a math student. Pretty early in the semester, I want us to think about what our goals are, our expectations, and also start thinking about what math class you plan on taking next year. So go ahead, pause the video, write down some ideas about yourself, and if you'd like to share them with me, I'm always happy to hear what your goals are for the remainder of the year. Okay, so you've either done this or you've chosen not to. I always like reflecting and setting goals. I think it's really important. And onto this chapter, onto this lesson. Okay, today we're going to continue using slope, and we'll learn about the y-intercept, the three forms here of the equation, and parallel and perpendicular lines. So once again, pause the video if you'd like to copy this vocabulary. We will see it throughout the lesson as we dive into it. So, what do we remember about graphing linear equations? And where have you struggled in the past? So go ahead, pause the video, write down your ideas, and then we continue onward. Answers I've heard students say in the past. Okay, well, I just make my graph and I put there's a line from one point to another and stop. Well, you got to make a line, it's got to have arrows on either end. Okay, these linear functions are going to go on forever. We got to make sure we label and scale our axes. So we got to say which one the x and which one the y is, and are we going up by ones or twos or threes or fours? And then we got to mark at least two accurate points. Some people just mark the y-intercept and then draw a random line. We don't want to do that. Other things I've heard, well, my lines aren't good at being straight. Well, then we get a ruler or a straight edge. I want us to be accurate and precise. And then this bottom question's for you. I do not know where you're going to struggle with graphing yet, but if you're struggling, we will work on it together. So now there's at least three forms. These are the three most common forms that I will see for the equation of a line. Slope-intercept form, point-slope form, and standard form. We're going to discuss how they look, what information they tell us, and how to graph using them. So, slope-intercept form. The name tends to give away what it tells us. It tells us the slope and the intercept, specifically the y-intercept. So this is the form y equals mx plus b. We've all seen it many times before, where m is the slope, b is the y-intercept, and xy is a point that makes the equation true. So it's any point on the line. But I need to know the slope and the y-intercept in order to graph. So we have an example, y equals 3x minus 2. We're going to graph this one. So have graph paper out and be ready. First thing I see is my slope is 3. I like to write it as a fraction because it means up 3 to the right 1. And my b, my y-intercept, is negative 2. So I have two really good pieces of information that I can put on a graph. Sometimes I also like to write it in words or I think about it. What does this tell me to do? It says start at the y-intercept, so start at 0, negative 2, then go up 3 and over 1. And when I say over, I almost always mean right. Probably should have said go right 1. So let's graph this. Well, I started at 0, -2. I go up 3, 1, 2, 3, and to the right 1. And I put another point. I put 2 points. I put a straight line through it. I should have arrows on the end of this, but I used computer software, which doesn't allow me to put arrows on it. So a linear function in slope-intercept form will tell me where my starting point is, where my y-intercept is, and then how to get to the next point. Gives me like a roadmap. Now, point slope form gives me slightly different information. So point slope form still gives me my slope, but then gives me a point, and it doesn't have to be the y-intercept. So the last one, slope-intercept form, was very specific. It gave me the intercept. This one gives me just any point. So x1, y1 is any point on the line. I like using this form if they give me a graph, because sometimes I'm too lazy to find the y-intercept. I just like any point. Okay, and then once again, x and y is every other point on the line. So this one we can choose whatever point we want to. Unless they give us an equation, they tell us which point we start with. Now see here, it's x minus x1. So I like to think of it as the opposite of this number. So the opposite of -1 is my x, and then this number is my y value for my point. So my slope is still 3. But this time my point is the opposite of -1, which is 1, comma, 1. So this one I'm going to start at 1, 1, and then use my slope. So I still go up 3 into the right 1, but I just start at a different point. I don't start on my intercept. So in this case, I started at 1, 1, I went up 3 and over 1, and I would have probably graphed that point as well, and then put a straight line through it. If you want to go down 3 into the left one, that's fine, but just make sure if you've got a positive slope, your line's going up and to the right. Now, the cool thing about this is I could have chose 2, 4 as my point and rewrote the equation as y equals 3 times x minus 2 plus 4. And those are equivalent equations. Both those will graph the same exact line. And I could have chose 0, -2. Or I could distribute this and I could put this in slope-intercept form. All of them are equivalent. Each equation is fine. If I don't tell you which form to put it in, if I say write me the equation of a line, you could do it in point slope form, or you could do it in slope intercept form, or if you're daring enough, we're going to learn about standard form. So now standard form is a form where there's a constant on one side and both variables are on the same side. Now there's a few rules for this. A has to be positive, and B can't be 0, because if B is 0, then this second part is gone. 0 times y is 0. So we just have ax equals c, and that's not a function. We also like a to be positive, and we can always manipulate the equation to make that true. Now this form helps us find our intercepts. This form doesn't give us our slope right away. It doesn't give us a random point right away. But we can find 2 points. We can find the x-intercept and the y-intercept. Now, these bottom 2 pieces of information are going to be super useful for every function we're ever going to deal with. The x-intercept, which is on the x-axis, always has a value of y equals 0. The x-intercept has no height, y equals 0. Y-intercept is right in the middle, it's not left or it's not right, so x equals 0. We're going to use those in the equation to solve. So let's take an example, we'll try it out. X plus 4y equals 8. I'm going to start with the x-intercept, which tells me to put 0 in for y. Now you can show as many steps as you need to do this. Eventually I just cover up the y part and then see that x equals 8. But we can always put in 0 for y. X plus 4 times 0 equals 8. It simplifies down to x equals 8. And I like to write it as a coordinate point. Because if I write x equals 8, sometimes I forget where to put it on the graph. We do the same thing with the y-intercept. We start with x equals 0, so put 0 in our equation for x. And notice I always put it in parentheses just in case there's a negative sign I have to deal with. 0 plus 4y equals 8. Okay, I wind up with just 4y equals 8 and y equals 2, and I write it as the y-intercept, 0, 2. And I like to write them as coordinate points. Each thing I do is meaningful to me. It's purposeful. I write it so that I remember, okay, I know where to graph 8, 0. I can graph 0, 2. And once again, I got 2 points, I can put a straight line through it. This problem didn't tell me to find the slope. Now if I need to find the slope, I go down 2 and write 8. So the slope is negative 2 over 8 or negative 1 over 4. But if it says just graph it, all I need is 2 points. It could be the x and y intercept. It could be the slope. The slope will help me find points. But either way, got to graph 2 points. Now, your turn. Using graph paper, not random line paper. I want graph paper. I want complete, accurate graphs with scales and labels and 2 clearly labeled points and a ruler with a straight line. So go ahead and pause the video, try these out, and when you're ready, you'll check your answers. Okay, so here come the answers. Let's start with the first one, y equals negative 4x. Yeah, this is really negative 4x plus 0, so my y-intercept is 0. I go down 4 to the right 1, and I can graph that. Okay, this one is in slope-intercept form. This one, another one, slope-intercept form. Start at a y-intercept of negative 3, go up 1 to the right 3. Got a positive slope, which means it's going up to the right. Straight line, labels, should put arrows on it, make it look accurate. This one's in function notation. Instead of y equals, it says f of x equals. Same thing. Now this one, I like to move the negative 4 first to make it a plus 4 so that I see my coordinate point is negative 2, comma 4, because it's the opposite of the middle. So we start at negative 2, 4, and my slope is up 5, right 3. So up 5, right 3, put a point, and I can graph it. Now this is point slope form. We can do that. As long as you get the 2 points, that's fine. If you want to distribute and put this into y equals mx plus b, you are welcome to, but it's not necessary. Now standard form. Okay, I can find my 2 intercepts. I can find my x-intercept by making y 0. I can find my y-intercept by making x 0. I can plot my 2 intercepts and I put a line through it. This problem I did not find the slope. But once again, if you want to convert everything to y equals mx plus b, it may take you more time, it might be less efficient, but you're welcome to do that. That's a valid method. I just don't always prefer to do that. And this is graphing in standard form. Now, here's some more examples. I recommend you pause the video. It's your turn now. You see equations, you see graphs. I want you to write the equations. I strongly recommend, since these all have the y-intercept, we probably would want to use slope-intercept form, but write them in any form you want. When you're ready, unpause the video. Okay, so here are our equations. First one, up 3, right 2. So y equals 3/2 is the slope. X plus 3 is my y-intercept. Here, positive 2 is my y-intercept. I go down 2, right 1. So negative 2x plus 2. And this one, the slope is 0. So I can write y equals 0x plus 2. But y equals 2, y equals is the equation of a horizontal line. Y equals 2 means a horizontal line at a height of 2. Now, all these have equivalent forms. So if you want to check with me and you wrote it in point slope form by you picking a point that's not the y-intercept, I'm okay with that. We will get plenty of practice on that as well. Now, the last part of this lesson is parallel and perpendicular lines. So go ahead, write down what you remember about parallel lines and their slopes and perpendicular. And if you don't remember anything, we'll share it. So, parallel lines, they have the same slope, same steepness, they will never cross. Parallel lines do not cross. The slopes are the same. So these two equations that I put here are examples of parallel lines. They have the same slope, different starting heights, never going to touch. They'll be railroad tracks. Now, perpendicular lines meet once at a 90-degree angle at a right angle, and their slopes are opposite reciprocals of each other. So if I have 3, I take the reciprocal and make it the opposite sign, so negative 1/3. Now here, the y-intercept doesn't matter in any of them. Just by looking at the slope, I can tell whether the lines are perpendicular, I can tell the lines are parallel, and then in most cases the lines are neither perpendicular nor parallel, they just touch once. So here's a challenge for you. We're going to practice writing the equations. So I want you to take the equation y equals 3x plus 4, and I want you to write an equation of a line parallel to it that goes through the origin. I want you to write an equation of a line perpendicular to it that goes through a point. If you want to graph them, you can. And then I want you to write an equation of a line parallel to f of x equals negative 4x that goes through a point. And you're welcome to graph any of them, check any of them. Pause the video if you'd like to try. And when you're ready, unpause it. I will walk you through some of these. Okay, let's take a look at the first one. So write the equation of a line parallel to y equals 3x plus 4 that goes through the origin. That tells me 2 pieces of information. I like to write it out. What tells me my slope has to be the same because they're parallel lines. And the origin is 0, 0, so my b value is 0. So y equals 3x. So parallel tells us the slope. It's got to give us a point. Since it gives us an intercept, I like it in slope-intercept form. Now the second one says equation of a line perpendicular and goes through a point. So I can find my perpendicular slope, y equals negative 1/3, or m equals negative 1/3. And I'm going to use point slope form because I don't know my y-intercept. I don't know my b value. I don't really want to spend the time finding it. If it tells me write it in slope intercept form, then I have to. But right now I could put in negative 6 for x1. I could put in 2 for y1. Remember, 2 negatives make a positive, and this is a nice form. Now, if I ever wanted to convert it, I can distribute the negative 1/3. I can combine like terms. I can get it into a different form. But as long as it says write an equation, I am just writing whatever equation is most efficient for me. And then the last one says parallel to negative 4x goes through the point 41. Same thing as the last one. Parallel means same slope. Put 4, 1 in the equation, and I have a nice equation. If I want to, I can distribute the negative 4 and get negative 4x plus 16 plus 1. I can combine like terms and get negative 4x plus 17 if the problem asks me to put it in slope-intercept form. And that's how we graph lines, and that's how we write equations given information. If I'm given a graph, I know how to write the equation. I need to know slope, some points. I can do this. If I'm given information about parallel and perpendicular, I know the slope. And once again, I can write the equation. Now go ahead and do some practice, and we're going to get really solid at writing equations and graphing lines.